General formula for carboxylic acid. CnH2n plus 1 COOH. And guys, carboxylic acid known as carboxyl group. And carboxylic acid is considered the most acidic organic compound. Oh, yeah, wait. Bro, my screen is lagging. Aiyo, wait. How like that, brother? AS sooner. Okay, guys, how we get ester? Carboxylic acid and alcohol. Alright, guys, now I want you guys to draw the ester here. Come, let's try. Okay.
I swear we did this last week.
No, we did not.
What did we do last week?
Last week we did carbonyl. We did not do this. I'm pretty sure. Yes. Someone knocked on the door, right? I'm not.
Ghost.
Alright, guys, please draw out. Let's go. I want you guys to form the ester here. Alright, guys, how to form an ester? So your carboxylic acid. Okay, so concentrated H2SO4. And you have to put it under reflux.
I don't know where the reflux on.
Okay, so to get an ester is always reflux.
There we go.
You get an ester.
No,
You know,
how much the acid get what?
react with itself. Yeah, react with itself. Correct. So guys, again, this is gonna react with itself. On one reason, you have alcohol here, guys. You know how to draw or not? Carboxylic acid is here, right? Correct or not? I did mention to you guys before how to draw a cyclic compound, right? OH is here. Okay, so these two gonna join here. Understand or not? Oh, should remember how to do it? Sure. So guys, basically, if you're not so sure, you can put number. Okay, so I'm gonna start from my carbon number 1. You see, my carbon number 1, 2, 3, 4, 5, 6. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. Okay, this I will split this. Okay, guys. Now let's look at your. I know that, right? This double bond O, you see the carbon number 1 is gonna join with the O that's bonded to 5. It's gonna join with the O bonded to 5. Can see or not? One more time. Carbon number 1, double bond O, join with the O bonded to a 5. 1 join with O bonded to 5, and 1 that's still a double bond O. Can you see your ester linkage? Right? But guys, don't forget, you still have your 6 here. So I have to draw another leg 6. That's branching out like that. Can see 1, 2, 3, 4, 5, 6. Guys, what else? 2, there's a leg. 3, there's a leg. 2, there's a leg. 3, there's a leg. Done. Okay, and a H2O is formed. That's how you draw your cyclic compound, guys. Okay, I'm training you guys how to do cyclic, yeah. Alright, guys, next. Physical property of carboxylic acid and ester. So carboxylic acid and high melting point and boiling point of carboxylic acid, right, is relatively higher, yeah. Why? Due to the presence of a hydrogen bonding. You guys know how to draw a hydrogen bonding? Okay, I have a delta minus here and a delta plus here. Okay, I can join it with another carboxylic acid. Okay, hydrogen joined with the lone pair. That is your hydrogen bonding. Done. Okay. Alright guys, carboxylic acid are soluble in water. Okay, they are weak acid because their molecule dissociate just partially. Yeah. Done. The next page. Okay guys, what about ester? Most of the ester, right, are insoluble, I remember. Okay, so small ester are finally fairly soluble compared to, okay, but if you increase the chain length, it's not going to be soluble anymore. And ester have a fruity and sweet smell, always used as fragrance here. Done. Alright guys, next, a reaction to form carboxylic acid. The first one, yeah, is you have a nitrile under acid hydrolysis, yeah. So guys, you should remember how to form the equation or not. Alright guys, I have this nitrile and I'm about to add H2O in it. And you have to add a HCl here. Okay, this time I'm adding a HCl. Guys, please draw the product. Go.
A salt.
It forms a carboxylic acid, not a salt.
Like side.
Yes, the side product, the byproduct, it's a salt. Hmm. And it's 4Cl. Good job. Alright guys, you see how whenever you have a nitrile, you are breaking this triple bond end, yeah? So this triple bond end is no more. And it's gonna turn into a double bond O. OH, right? Remember, it's gonna turn into a carboxylic acid. And the nitrogen is gonna turn into an NH4 plus Cl minus. A salt is produced. To balance the equation, 2H2O. Done. Understand? Alright guys, that is the first way you can get a carboxylic acid. The second way you can get a carboxylic acid is when you oxidize a ketone, oxidize an aldehyde. So guys, let me show you one example. Alright, guys, let's go. Huh? No, oxidation means adding oxygen. A carboxylic acid is formed, guys. Aldehyde oxidized to turn into a carboxylic acid. Let's go. Okay, when you oxidize it, this will turn into a carboxylic acid. So basically, you just have to add an OH here. You just have to add an OH here. It's gonna turn into 2 carboxylic acid. Add a 2. Done. That's it. Correct or not? Okay, know how to draw? I'm gonna give you guys more and more reactions. I want you guys to draw, keep drawing and keep drawing. Alright, guys, next. What if you are given an alcohol? I can also oxidize an alcohol to get a carboxylic acid. Alright, that's it. Alright, guys, please oxidize this for me. Okay, the condition is I want you guys to oxidize it under acidified K2Cr2O7 and reflux. Go. Alright, guys, again, a primary alcohol is gonna get oxidized into what? By the way, this is a secondary, a tertiary, and a primary. So primary is gonna get oxidized into a carboxylic acid. Understand or not? Yes, okay, and tertiary cannot be oxidized. Secondary can turn into a ketone. Stop. Hello? I'm muted. I just realized I'm muted. Oh my god, bro. Okay, guys. Again, you see, right? You have 2H2O here on one reason. You have 1H2H. This one got no more H's. So 2H here. Then the 2H's here are removed also. So you have 2 more H's. So in total, it's going to be 2H2O, yeah. Okay, last one. Alright, guys. Oxidation of alkene. Okay, I'm going to give you a fun one. Well, if you can do this, means you're damn good, bro. I hope you guys can do this. Alright, let's go. Hot concentrated KMnO4. Alright, guys, now let's begin. What's the time to? Hey, wait, no, not order your Nando's one.
No. Cutting seaweed. Continuing.
And bulking and cutting, I cannot lah. Must rub together. Hey guys, you cut it here, yeah. And when you see a cyclic, I did mention to you many times, put number. Okay, so it's gonna be 6, 7 carbon, yeah. 6, 7. Your favorite number, right? 1, 2, 3, 4, 5, 6, 7. That's it. Alright guys, the first carbon what's gonna turn into? You see this C11, right, is bonded to 1C, 1H. If it's 1C and 1H, it's definitely gonna turn into a carboxylic acid, yeah. Alright, 3, that's a ding ding. I extend the ding ding on 3. 4, 5, 6, 7, and 6. Alright, guys, let's look at this. It's bonded to 1C and a 2C. So if it's bonded to 2C, after oxidizing, it's going to turn into a double bond O. That's it. Okay, so guys, how many oxygen we are adding? 3. Done. Please write it down. All good. Alright, guys, done. How can we test for carboxylic acid? Correct. We add sodium carbonate and then 2CO3. Positive result. Effervescence boson. Reason? CO2 gas. Okay, please write down. Alright, guys, I'm going to give you an example. Alright, guys, please balance the equation for me. Let's go. Guys, what is going to turn into? So, guys, your Na is going to replace your OH. So the H is going to get removed. So you get the ONA. H2O, CO2. So to balance the equation, 2 acid, 2 acid. That's it. Alright, guys, next. Alright, guys, why sodium matter? Let's say, like, okay, I want you guys to write a Q here. Alright, guys, why sodium matter, right, is not suitable to be used to test? Why sodium metal is not suitable to use to test for COOH? What's the reason? Anyone?
Yes, with the alcohol.
Yes, correct. So Na reacts with alcohol too. So which is why we don't use sodium to test for carboxylic acid. Because if you have an alcohol, it's going to react with alcohol too. Good job. All right, guys, write it down. We are moving on. Why Na displace H? Because Na is more reactive than H. Na is a better oxidizing agent. Oh, sorry, Na is a better reducing agent, my bad. All right, guys, now I'm going to give you 3 equations. I want you guys to balance it. So if I take a carboxylic acid, I add with a KOH, please tell me what's your answer. I reactive with a reactive metal such as barium. What's your answer? I reacted with a carbonate. What's your answer? Go. Please write it down. This is easy. All right, guys, the first one, what's going to turn into? C2H5 cook plus H2O, correct or not? Second one, CO bracket 2Ba plus hydrogen gas. Put the 2 to balance it. Done. Next, C3H7 COOCA kuka. Put the 2 to balance it. That's it. Okay, guys, please share your answer. And once done, let's move on. We are almost done it. Last page. I said we only left with honeymoon chapter. Yeah, we have one more chapter coming. I'm not finished. Okay, come in first. Alright, guys, next. Reduction of carboxylic acid. Alright, guys. How we can reduce the carboxylic acid, right? It's always using LiAlH4, yeah. Okay. Alright, guys. Reduction of a propanol acid. I want you guys to balance the equation for me. At the same time, guys, I want you guys to reduce this compound for me. Yep, it's for me. Thank you so much. For faster asking. Hey, faster tutor my teach her how to do magic trick. Teaching. See you in 20 minutes. See you in 20 minutes. Well, boy, gonna start the lesson in 20 minutes. Huh? What's Ushari? Really mad. Never tried. Alright, guys, balance the equation and draw the product for me now. Using LiAlH4. Hmm? Yes, it will form alcohol, correct. Done? Alright guys, the top part is going to turn into a C2H5, CH3OH, right? Correct now. Okay, then the oxygen is removed as a H2O, yeah. So how many hydrogen we're adding in? 1, 2. I cannot see again. Oh my god. Okay, you get a CH2OH. Okay, so how many hydrogen we're adding? 1, 2, 3, 4, 4H. That's it. Alright guys, next. We have a C double bond OOH. Oxidized state is going to turn to this one gone. Basically, you are adding 2 hydrogen here, right? This one also you add another 2 hydrogen. So in total, you are adding 4 hydrogen now. Yeah. What happens to the other double bond O? This one, it get reduced also because this is a ketone, right? Ketone can be reduced into the other one, this one, it's gone completely. Oh, my bad. It's gonna turn into a H2O. Thanks. So 6H2. Yeah, you're right. I'm missing out a H2O. Thank you. Alright guys, finally esterification. I'm just gonna give you the last one. I want you guys to draw it out. Alright guys, draw the product for me. Let's go. Oh, not done. Both double bond different, as in one is aldehyde, one is ketone. No, this is ketone. So this this is a carboxylic acid. How can it be aldehyde? Understand or not? It's a carboxylic acid. Okay, I highlight for you already. Okay, guys, come do the last one, and we can wrap this chapter up already. I'm sending a new chapter over. Please download this. Alright, guys, new chapter is sent in your WhatsApp. So in your Zoom chat, please download it. And that will be the last chapter of AS.
It's all full cycle also.
Yeah, I really love cyclic. I keep giving you guys cyclic for a reason. I need to train you guys to do cyclic. No problem, Gloria. For you, since you listen to Eason song also, for you, I send it. Okay. Sending now. Alright, guys, last one. Anyone got the answer? Or anyone want to impress me? Alright, guys, let's go. Alright, can you see, right? I always remove OH from my carboxylic acid. Correct or not? I remove H from alcohol. I just have to merge them. No more. No more, correct or not? And it's gonna merge into an O, right? Correct or not? This is also gonna merge into an O. So guys, let's look at O. What O is merged into? 1, 2, 3, 4. O is gonna merge into the second carbon, merge into a third carbon. That's it. Law. Can you see a 1, 2, 3, 4 here? And a H2O is formed. 2 H2O, in fact. Nice or not, my face? Fun, Okay, guys, please go it out and please download chapter 19. Can I repeat, can? I remove OH. No more OH. I remove OH, no more OH, cannot. This is always gonna bond into the O, right? Ester is always C double bond O, then O. So bond here. Or can you see this bond here? Then this part bond here. So you see, let's say if this part bond here, then O to the second carbon, right? You see O to the second carbon, then to a third carbon, then to O again, then bond back. Understand? Cyclic compound we have done so many times already, guys. And please write it down. We are wrapping up.